So typically I've just forgotten that. Okay, so we're talking about webinars. We also have face-to-face conferences. That's also there. We conducted one conference, I guess in April, and that was completely devoted to DevOps as a theme. We have plans to conduct at least a couple of more conferences in 2018. So that's typically what we do. Moving on to the next slide. Just one sec. So the next face-to-face conference is planned in the month of August. August 4th is the tentative date that we are looking at, being Saturday. The theme is not yet identified. There is a recommendation that artificial intelligence and machine learning could be a theme that we could take up. Last time that is a theme that I had put forth, but we are open to actually any theme that is cutting edge, that is relevant and that's useful to a lot of people. So that's the whole idea of having webinars and conferences. So we have to be very careful in identifying a theme so that it gets maximum attention among the members and many more outside also. So the venue is also yet to be identified. Typically, we do it in a company who could host us. Around 50 people join the conference, approximately 40 to 50. So we need a place in any organization who are willing to host us. A conference room with a nice projector with around 40 to 50 people seating capacity is what is required. Last conference was held in Micro Focus, so they were courteous enough to space there. So if you are willing to, if your company is willing to, host a conference like this, it would be beneficial to the company also, because there will be a lot of people from the company who will be directly attending. So and they also get a chance to meet community members. So if you are interested, if you are willing, if you could talk to your organization folks and help us conduct this conference, that would be very good. Maybe you can start looking at it from now itself, because August 4th is not too far away, although we have 1 month's time to actually plan and execute. It would be good if we can finalize the venue sooner than later. And typically we take up keynote presentation by an expert in the industry, a demo, multiple demos, presentations, and then panel discussion. That's a format that we have been following so far in our webinars and conferences. But we are open. I'm open to taking up anything that is relevant. The organizing committee is not yet identified. Anybody who is willing to take active participation in conducting this conference, taking up some responsibilities, it's an opportunity also to actually do something which you have not done in your life. So let me know. I'll help you. So we can work together. It'll be pretty lean activity. It'll not be very tight. So probably once in a week we'll have some discussions and we will take it forward from there. Okay, few ideas would help us. We have been in a mode of having webinars and conferences, but we would like to improve collaboration between community members better. We would like to have more collaborative way of working. I know that a lot of our members have a lot of ideas. So one thing that I would like to hear from the rest of the members is what are the various mechanisms by which we could improve collaboration among the community members. What are the activities that we could take apart from webinars and conferences? Somebody on the day was saying that people can actually record some videos and upload it in our YouTube channel. That need not be a planned activity. It could be an offline activity too. And let the community members know that this video has been uploaded. It's one of the ideas. So like that, I'm sure that a lot of us have got different ideas. So let us discuss those ideas on WhatsApp or email. Anything is fine. And also what topics we could take in our webinars and conferences. That is something that we would like to know. And the other very important is to get more and more people in our community. because only when we are a large group, there'll be more opinions and ideas from members. So with that in place, I would like you to recommend your colleagues and your friends to join this community and get benefited. Okay, so with that, I would like to pass on the baton to Anup. Thank you once again, all of you, for joining. Thanks, Anup, for taking up this presentation. The demo is on DevOps, CI pipeline, continuous integration pipeline. One request is, if you have any pressing questions, you can always stop and ask, no problem. But in case if some of your questions you could mark it and reserve it for till the Q&A session, that would be very, very helpful. Okay. So with that, let me pass the presentation rights to Anup. Anup, are you there?
Yes, Krishna. Thanks, Krishna.
Excellent. So we will, at the end of Anup's presentation, we will have a core team members meeting. So I would request all core team members to stay back for around half an hour, and there are a few things that we would like to discuss. So yeah, Anup, will just give me 1 minute. I'll change the presentation to you. Okay, Anup, you are the presenter.
Okay, can you see my screen?
Yes.
Okay, good morning, everyone. I hear a lot of echo.
Oh, okay. Let me mute everyone. Just one sec. Go ahead, Anup. Yeah, Anup, you can proceed.
Okay. So this is going to be a presentation plus demo. So before getting into the demo, I will probably brush up a little bit about the DevOps. I still hear the echo. Can you mute, please?
Oh, really? Okay. May I request all participants to mute, please? Or maybe I should mute. Maybe the echo might be coming from me. One second.
Okay. So this is going to be the agenda, and so I'll slightly touch upon the DevOps to basically bring everyone to the same state, and then we get into more details of continuous integration and CI pipeline, and we'll have demo of various things. So I have a few slides to basically list down the number of tools we have used that we probably can be reused later or that can be referenced later. And then we can open up for a question and answer session. So the DevOps in terms of definition, right? So this is the Wikipedia definition, which is basically the DevOps is unifying the software development and software operations. So that is something which in my team, at least, we had a lot of learnings which we had to go through to get into this state. And so the unifying process itself is a little different than combining any other process. So I'll get to the so it's basically considered like a DevOps movement, so which strongly advocate automation and monitoring of all the steps. So including integration, testing, releasing, and infrastructure management. So the last point of infrastructure management, which we generally were not doing during the probably 5 years back, right? So that is very much important here, and the automation of the infrastructure management is very much important to get into the DevOps movement. So these are the basic stages in a DevOps. So you start with planning, coding, build, and test, and then you move to the deploy, operate, monitor, and so this cycle keeps going. So it's go like in this direction, and it keeps going. So the blue color, what we have mentioned, is going to be the continuous integration, and the orange color, yeah, orange color or whatever color is that. So that on the right side, right? So on the right side, that is called going to be the continuous deployment. So what I would be more focusing on in this session is on the continuous integration. So as I said, DevOps, it is not really a unifying of technologies or tools. It is basically much more than that. So initially we felt that okay, we can get multiple tools and get integrated and automated, and then we are there in DevOps. But it doesn't work like that. So it really needs breaking down of all the barriers between each engineering group or each function. So working as the whole team should be working as whole team or whole different functions in the total development team, right? So including the project management and including the release function, testing, the automation team, and the development. All of them need to be working as one team, and only then that change or the DevOps movement will really happen. Otherwise, we can automate it, and then you can see that the DevOps getting failed because people are not really feeling as unified, and people are not working as one team. And so that makes the collaboration and communication most important. And so without collaborating between different functions, this DevOps is not going to be a success. So as I said in the previous slide, so the infrastructure also needs to be treated as code here. So we generally treat the product coded by the development as only the code which are going to be used, but in DevOps, the infrastructure becomes part of the code. And one important thing is that there is no way you can achieve DevOps without automating everything. So you having different places with assigned to manual steps or manual tasks, we are not going to be succeeding in DevOps. So automating everything has to be a mandatory step for the DevOps. And test, measure, and monitor all the steps and all the time. So even if it is CI or if it is CD, you have to be monitoring everything, and you need to be feeding back to the entire cycle. So it's basically a unifying stuff which has to happen between the technology and also the culture. The cultural change is the more difficult part, and that has to happen to achieve success in DevOps. So these are the different tools. So if you look at the tools in the web, right? So if you browse through the different tools in web for DevOps, you find humongous number of tools. So whatever I have listed down here are some of the major ones or some of the popular ones. So in this slide as well, the blue color section is for the CI, and orange color is for the CD, right? So here you can see that for coding purpose, you can use the Eclipse or any IDEs like that, IntelliJ or Eclipse or anything. And for the code storage, right? So or the code checking, right? So you can use Git or Jira or anything. So, and then if you look at the build, you can use Gradle, Maven, Apache. And so any of these tools can be used for the DevOps integration, but the point which needs to be noted or point needs to be stressed upon is that you need to be finding the best tool out of it. So all of these tools, if I have to really compare between these tools, most of them will be able to do all of the requirements, but when you will have specific requirements. So based on your specific needs, you need to pick and choose the tool. So that is where the success lies. So in our case, what we have done here is for in the development, we are using the Eclipse, and in fact, we are using IntelliJ as well recently for some of the stuff. Like the automation team, we are using IntelliJ for the IDE. And for the code checking and management, we are using the Git. And for the continuous integration, we are using Jenkins. And for building the code, we are using the Gradle. So it doesn't mean that you cannot use other tools in that function, but we have selected these as we have found that these are the tools which will help in most of our tasks. And for automation purpose, for unit testing as well as for the integration automation, we use JUnit and Selenium. So in fact, we are using the Spoke framework, which is based on the JUnit. And for basically the deployment purpose, we are using Ansible. So even though Puppet and Chef also do the same type of stuff, we found Ansible is moreover like agentless and stuff like that. So we felt Ansible is the right tool for us. So far, any questions? Or probably you can ask the questions at the end as well. But if anything is, you feel that it needs to be answered now, you can probably ask that now.
I have one question, Anup. So, TeamCity comes under both build and deployment tool, or it's only deployment tool?
Which one? Which tool are you talking about?
TeamCity.
I think it's deployment part of it. I don't have that much experience about that tool. So anyone else?
This is Naresh here. So TeamCity is basically a continuous integration tool like Jenkins. It's like Bamboo and Jenkins, yeah.
Means we can do both build and deployment from the same tool, or it's only for deployment?
Yeah, you can create builds using it, release builds using it. So build tools are like Maven and Gradle, those kind of, and Maven, Gradle are your build tools, right? So it's more of it's more of the creating the pipeline and everything, right? So you use Jenkins and Bamboo, the CI tools, right? So TeamCity is very similar to that. TeamCity is like basically like Jenkins.
Thanks, Naresh. And yeah, as I said, there are many number of tools outside this, whatever I have listed here. So it's basically a lot of tools does the same stuff, but you have to pick and choose. So I do not have any experience with TeamCity, and thanks, Naresh, for answering that. So let me proceed. So we felt that so the DevOps is mostly done for the service model, in fact, so the product or the what you call software as a service model, right? So even though DevOps is being implemented in different other projects which are enterprise level, but mostly DevOps are implemented for the service model, and that makes it very important that the security is really part of each of your DevOps function. So that is where this slide really makes it important, and there is a term itself coined basically called DevSecOps, where security is being injected to all of these stages. So we have tried to inject the security in basically the design section itself and during the CA as well. So I'll talk about it later. Okay, so the continuous integration on a very high level is basically this. So we have developers writing the code and they checking the code into the source control server, and this is basically the continuous integration server which fetches the changes build, test, and so report the failure or success, and the notification of success or failure will be reported to whoever is the stakeholders as well as the developers. So this is on a very high level. This is going to be the continuous integrations, and the entire flow has to be automated. So that's where the success lies. So any of these tasks, if you leave it for manual tasks, then DevOps cannot be a success. So I'm quickly moving all through these slides, basically because I remember that we have been covering this in past couple of webinars. So this slide is mainly to ensure that, or really stress upon the fact that you have to automate everything. So automate build, deployment, test, tool execution, and event reporting. Okay, and yeah, as I said in the previous slide, the success mantra is basically everyone in the team owns the CI pipeline. So if they all of them are not monitoring or are not owning up the CI pipeline, it cannot be a success. So any failure in the CI pipeline has to be fixed immediately. So it could be from the development, it could be from the testing, or it could be from the deployment team, like say your Kubernetes setup is not up. So any of those issues can break the CI pipeline, and so this fixing the CI pipeline becomes the prime responsibility of the team, and every member of the team has to really be focusing on doing that. So that is something which needs to be ensured by the team or the management. And yeah, so the entire team is responsible for the success of the CI pipeline. And so though we say that everyone is working as a single team, the core roles of developer or tester won't change. So developer will be still writing the code which is achieving the functionality, and tester will be writing the testing code. But there could be an overlap you can do a lot of things to succeed, right? So fixing some small stuff like a unit test, which is actually breaking the CI pipeline. So the tester can get access to the code, and then tester can actually go and fix those unit tests and then get the CI pipeline running for the build to succeed. So there are going to be a little bit of overlap, though the core roles are not changing. And yeah, so fully automated test, so that means that the entire integration, entire cycle would be tested for all the builds or for all the changes. So it means that you can detect the problems very early in the cycle. And the main objective is that never break the CI pipeline. So none of the things which are basically not stable would be part of the main branch. So you will not be even allowed to check in if the CI pipeline is not succeeded. And the quality gate is the one which actually defines the readiness to release. So it can be defined by each team can define the quality gate in whatever ways or whatever is the criteria which they want. But a sample one would be like the percentage of unit tests passed, percentage of functional tests passed, or percentage of code coverage, and number of severe, critical, medium vulnerabilities found. So with that, yeah. So as I said, so you can pick up the most prominent and popular tools, but that doesn't really make CI. So you need to really integrate these tools and pick the right tools which will satisfy your requirements. And you might find that some of the tools are very close to your needs, but there could be, you need to basically research a little more on the tools which will help in your environment. Okay, and so if I don't know how many of you understand. Yeah.
A quick observation. Basically, Just to add to what Anup said, one thing that I understand by DevOps is typically when you say everything needs to be automated in a non-DevOps environment, if you look at Dev versus QE or Dev and QE, typically automation is left to QE's responsibility, whether it is automated or not. As long as the timelines are met, nobody really cares. However, there is always a recommendation that automation is done, but it's mostly seen as a responsibility of the QE department, right? In DevOps, since automation is the success mantra, it's the main thing that you need to automate almost everything. I think the whole responsibility lies with the team, and Dev and QE will have to work together to make sure that automation is very successful. Am I right on this?
Yes, Krishna.
Okay.
So in our team, so what we have done is, I think the echo is coming from you, Krishna. Thank you. So in our team, what we have done is we have basically picked up the unit testing as well as the functional testing using the same framework, which is the Spoke framework. And what that really helps us is that, as I said, some of the unit tests can be written by the test engineers as well as the dev team. When they are actually available, they can really come and write the functional test as well. So that basically becomes an easier way to really utilize the time of the team. So at the end, the team has to basically own the entire CI pipeline. So the code coverage is achieved by not only the unit test or the functional test. So it is basically a mix of all the type of test, and so adding unit test, sufficient unit test, and at the same time adding sufficient functional test is the responsibility of the whole team, not only the development team or not only the test team. So that can be achieved by using something the same framework, so which basically reduces the learning curve. Okay, so the pipeline or the CI pipeline, basically we are achieving using the Jenkins pipeline, and so what we are doing basically is like this. So the developer, this is basically a detailed view of the previous slide, a couple of slides before I had shown about a high-level continuous integration. So this is going to be the real stage-wise transition of the continuous integration. So developer is going to commit the changes to Git, and so it is basically hosted on a Bitbucket server. And the Jenkins, based on the changes and the pull request, Jenkins will trigger the build, and which is nothing but Jenkins will check out the code and then build and then start the unit test. And so once the unit tests are passed, it is published, it is basically gonna create a Docker. So in our environment, so we are using Docker, so I mostly would be talking in terms of Docker and Kubernetes and stuff. So, but any containers is actually can be used. So I would be probably taking the term as Docker and Kubernetes and stuff, mainly to ease out the presentation. So publishing Docker and to the Kubernetes, and then so once the services are up for the test, automated tests would be executed, and then security tools would be run. And so after all of these, from various stages, the results are being gathered, and then it goes to the quality gate. So quality gate will decide based on the, as I said, the example of percentage of unit tests passed or number of vulnerabilities found and stuff like that. Based on that, quality gate will decide whether this build is of good quality, which can go to the next stage. So it reports, and we can deploy to the staging environment, which is basically a next environment. So you can have any number of environments. So you can have a dev environment, then you can have a test environment, then staging, and then you can move to production. So this is going to be the one stage of the continuous integration, if I say, like if you have multiple environments. But each environment, the cycle could be more of similar, though the task within each of these boxes, right, would be a little different to ensure that the objective of that stage is met. Okay. Okay, so Jenkins pipeline is basically I have added these slides to ensure that so all of you people are able to understand about the Jenkins details. So some of the cases in some team this may be started based on, or the template might be given by the CM engineers and stuff like that. But yeah, so everyone can understand and everyone should be able to understand the entire pipeline. So we should basically start from the infrastructure piece. So the Jenkins pipeline is basically a text file and it's called Jenkins file. And so this can be checked into the source control repository. So that is the very important thing. So I'll start off the infrastructure as code, right? So the Jenkins file, which is actually running the pipeline, which includes the infrastructure, which includes the security tool execution, all of these are part of your source control repository. So Jenkins can pull this Jenkins file and then run through the entire pipeline in each version. So for each check-in that can be done. So that is one very important aspect here, that the entire pipeline is, or the structure of the pipeline itself is being checked into the source control repository. And basically pipelines are made up of multiple steps that allow you to build, test, and deploy applications. So step is like a single command which performs a single action. So when I say that it is a single command, it can include multiple commands. So, but to get an idea, so each step is nothing but you are say it can be like a shell script which is running the functional automation. So which is basically triggering a functional automation which includes multiple steps within itself. But so that can be one command which is basically a step which is called a functional automation. And so there are different stages, and so you can say then so pipeline in progress is like one stage, basically each step, right? So when a step succeeds, the pipeline proceeds to the next step. And whenever a step is failed to execute correctly, or there are some infrastructure problems as well, so pipeline fails and come out of it. So all the steps in the pipeline, if they are successfully completed, then only the complete pipeline is succeeded. So I will have this stuff covered in the demo. So so this is how it is going to be looking like, the basic Jenkins pipeline file, where the first line, which is called the agent, where that is where basically the entire pipeline is going to be executed. So yesterday in our group there was some discussion around the master Jenkins and slave Jenkins and stuff like that. So here this can be used here. So the agent is nothing but a slave node or whatever, where you are basically running the entire pipeline. So master triggers this step and hands over to the slave here. So if based on the number of slaves, so if you configure it as agent any, it means that any of the slave can pick it up. And these are the some of the environments, so variables which you can set up. So mostly what we do is in each build you give a build number and stuff, right? So and let's say the path for the Java home and stuff like that. So the environment variable setup you can do with this environment block. And then comes the stages. So these are the different stages which I really showed you in the pipeline, which basically talks about the deployment, the functional test, the security test, and stuff like that. So the stages can be a number of stages. You can keep adding stages. You can divide the stages into multiple steps. And in each stage, there can be multiple steps which can be run in parallel as well. So that is one very important or very useful stuff which we have been using. So some of the stuff like deployment of one Docker container, it can happen in parallel with deployment of other, say, 10 Docker containers. So all of these can be done in parallel, and that can be like a parallel step in the each stage. Okay, so this is the next section or the next block of the pipeline, where the post execution of the pipeline, what you need to do. So when there's a failure, you can send a mail to the team, or so whatever, or different actions can be done. So you can even send a message to the Slack. You can send, I mean, based on the plugins you have installed in your Jenkins, you can do a lot of these actions. Okay, and so the post can have multiple steps, which will, so there are multiple blocks which you can use, where say mostly what we do is after every pipeline is done, you have to clean up the entire environment, right? So that can be put into the always block, where after all of them are finished, you have to clean up the setup. So whatever, even if it is failure or if it is success, you have to basically clean up the environment. After copying the insufficient or relevant log files or whatever, you have to basically clean up. So that can go into the always block, and the success block can really have something like the moving the build or moving the code to next stage, or checking the code to a different branch, right? So those are the things which you can move to the success part. Unstable, yeah, so you can add different steps based on your requirements. So failure, whatever you want, you can send a mail to people. All of those you can basically do. Okay, so this is another part of it. So as I said, so the stages can be multiple stages: build, test, deploy. So that is something which I showed in the block. Then another type of stage is like deploy staging and deploy production. So you can basically that's where the multi-branch pipeline in the Jenkins come into picture. So based on the code in different branch, you can actually pick up different Jenkins file as well, and you can have all the configuration or all the stages in the same Jenkins file, or you can have, based on the branch, you can have different Jenkins file as well. So pick up the right stuff based on the branch state. So multi-branch is nothing but you can use the same Jenkins file, but based on the branch, different sections of the stages will be executed. So if your branch is right now it's getting executed in the production stage, so those are some of the checks you can do in the Jenkins pipeline itself, and you can run different steps based on the branch. So this is the one, I don't know how many of you are using this Blue Ocean view. So this view in Jenkins, this is basically a plugin, Blue Ocean plugin, which can be installed on Jenkins. And so this view really gives a high-level dashboard type of a stuff based on what is going on in the CI pipeline. So this actually is really helpful, and this can be drilled down. So each of these tick marks can be drilled down, and you can understand like what is going on in that. So this gives a live view of what is happening in the Jenkins pipeline. So maybe I'll get to the demo right now, and so this is a live system. Can you still see my screen? It's a Windows PowerShell right now.
Yes.
Okay. So I had made some changes, and I'm basically using Git for committing it. And okay, So I basically I'm committing the changes to my branch, which is CI pipeline branch, which I have. So I'm not going to really explain about these git commands. So I committed and I'm pushing the changes too. Oh, okay. I probably will not be able to push my changes directly to the develop, so I will have to, let me just see. Yeah, so I need to, okay, it's taking some time. So once this is done, so what it says is that, okay, so the push has happened to the feature branch, which I have. This is my feature branch, which is CA pipeline. And what it says that you have to create a pull request for the feature CI pipeline. So what the environment which we are using, I mean, basically the stuff is basically plugged into the big bucket. And so what I need to really do after the checking is done. So these are the initial manual steps involved in the complete CI. So you have written the code and then you are checked in. So these are manual. And in terms of creating the where the pipeline is getting triggered, I will let you know. Like after the pull request is made, the pipeline gets triggered. So before that, I can tell you about, so where's the configuration for how you really initiate a pipeline. So if you look at the configure of Jenkins, right? So what we have done is the source, we have put it as the Bitbucket directly in Jenkins. This is basically the Jenkins configuration, okay? And what I have done is, so the branches which you are going to execute, so this is a multi-branch pipeline, and you can say that all the branches you can include it, and you can filter it out afterwards as well. So any of these feature check-in or bug fix or hot fix, none of them I would be basically executing. But when it is basically pulled to the develop branch, I would basically execute this pipeline. And how the pipeline is basically triggered is that, so building can happen in by Jenkins file mode, and the script part I've given is the Jenkins file. So in the root folder of my project, there is a folder called Jenkins, and then there is something called Jenkins file. So that is the file which I have for the complete pipeline. So this is the triggering point of the CI pipeline. So as soon as the branch check-in happens here, which is basically to the develop pull request, and then this Jenkins will basically get the Jenkins file. They look for the Jenkins file and start executing the steps which are mentioned in the Jenkins file. Okay, so this is the very basic part of what you have in the Jenkins configuration to basically integrate a pipeline. So if I have to explain each of these fields, it will take more time. So I will proceed from here. And so this is the Bitbucket where I have checked in my code from my local machine, and now the code is available in the Bitbucket, right? So now the next step is creating a pull request. So pull request is that, so I have pushed the file into my CI pipeline. So from the CI pipeline, so the develop is the branch which is going to be a stable branch, and so I am trying to basically make a pull request from CI pipeline to the develop branch, right? So when I continue here, so what happens is none of the check-ins are allowed to be really checked into the develop branch unless there is a successful build. So these are the configurations which you can do in, again, the Bitbucket. So I really do not have this like a production Bitbucket server, so I don't have the rights to show that. But there are configurations like how many builds you need to be succeeding before this change can be really checked into the develop branch. So when I trigger this check-in, so there is a PR build, so pull request build, which will get generated, and only on the success of that pull request build, it will be pushed to the develop branch. Okay, so I'll show it. And as well as on top of that, you can really mandate that there should be a reviewer, and the reviewer has to really enable. So how many reviewers you can, they need to show the green flag for you to check in as well. You can set it in the Bitbucket. So, okay, so right now I have disabled it so that the demo will go very fast. So now what you can see here is I have basically made the pull request, and as I said, the pull request, as soon as it finds the Jenkins, will look for the Jenkins file and start running the pipeline. So that you can see. Yeah. So if you look at the Jenkins, so it looks for a 2 minute interval. So it should trigger shortly. So if you see the pull requests which are made, so you can see that even though I made the pull request, I cannot merge this stuff into the what you call the develop branch. So you can see that you need a minimum of one successful build before this pull request can be merged. So this setting is done in the Bitbucket server, and that prevents you from merging the code to the develop branch. So this pull request has already triggered a build, so only the success of that build, you need to basically wait for that. Okay. Oh, it's taking a while. So, meanwhile, any questions till now? Am I making sense, or am I going really fast? Are we able to make sense out of what I'm showing? Hello?
Hello? Yeah, Anup, it's pretty clear. Good.
Okay. Any question? Any question?
The only thing is you used certain acronyms like Bitbucket and things like that, right? I'm not sure how many people would know that. I'm just guessing that people might be aware of a few things.
Yeah, so Bitbucket is nothing but, yeah, I mean, you can host a Git repository in a Bitbucket server.
Yeah.
So there are different tools. As I said, there are different tools available for all of this.
Krishnan, hi, Kurmi here. Hello?
Yes,
Okay. Go ahead.
Yeah, no, sorry. There's a lot of echo on the line.
Yeah, Krishnan, I think you are lying. So as you can see this. So this is the activity page where different builds happening and stuff you can see. So this is the branch you can see here. So the PR is nothing but a pull request. So the currently the build which is triggered automatically is the pull request build, which is basically a criteria to allow the developer to merge the code to the develop branch. So you can see that this is the pull request build which happened. And so as I said, in the pipeline, you can, so maybe I would probably open my pipeline file. So as I said, this is my project. So so inside the Jenkins, I had shown you that in the root folder of my project, there's a folder called Jenkins, and inside that Jenkins file. So this is what I've configured in the Jenkins to look for, right? So this is the Jenkins file, and this is how it looks like. So I had shown you sample in the presentation, and here I have basically specified the agent not as any, but there is a slave which is labeled as less12 So that's basically the node it is looking at. So that slave would have picked up this job and started executing. Okay, and as I said, the environment is here. I have put different Java home and stuff like that, and the build name, right? So the build number as well we have initiated in the environment. Okay, so
Anup, quick question. So who writes this pipeline file? I mean, do you write it while creating a pipeline in text mode, or is it like a tool available for writing this pipeline file?
So this I write it using a text mode.
Okay.
And you get different templates. As I said, you can get different templates, and you can even modify and stuff like that. But you can keep adding more stages. You can make stages running in parallel and different tasks in parallel and stuff like that. So those are things which are coming down. I'll show you that. So this two steps, agent and environment on top, and then the stage blocks will come in. So where you have, you can, so this is one stuff which I was talking about, the when condition, right? So based on the branch, so this is a multi-branch pipeline and which you have created, and based on the branch, you can decide whether these steps will execute or not. So this step, which is environment step, will not get executed. The environment step is actually skipped because it is not a develop branch. It is basically a pull request branch, and so this is not going to be executed. So you can skip different steps inside the pipeline based on the type of build which is, or type of the branch on which you are actually executing the pipeline. So the next one is the clean environment, which you don't have a when condition, so which means that all of these steps will get executed in that. So here what you have is nothing but, yeah, so all of the Docker files, whatever it was there, you are basically cleaning up the environment if anything was left out after the previous execution. And you are removing the report folder and stuff like that. So a lot of cleanup activities which you need to make sure that the environment is clean enough to start a execution, right? So that can be done. So this stage called clean environment, right? So these are all named by ourselves. So you can name whatever you want, and it's basically a meaningful text which you can put, a meaningful string which you can use. So next stage is, so this, after the completion or successful completion of this stage, it goes to the build or unit test. So you can see that what I am executing is, these are the Gradle tasks which I have. So we are using Gradle, as I said, for building the code. So these are the commands which, or the tasks which are Gradle tasks, which you can just call from the Jenkins pipeline. So what I'm trying to do initially is, after the successful completion of clean environment stage, I'm going to execute Gradle assemble, which is going to be compiling the code and then building it. And then at the end of that, you run the unit test of it. So you can see that, so this is what I was talking about. The clean environment is here. and the build unit test is running here. So once the build unit test, you can build out what is happening in that. So that is the beauty of this plugin. So you can see that Gradle assembly is going on, or finished, and these are the steps which happened in the Gradle assembly. So this plugin really gives a good view of how things are happening, and then it moves to the Gradle unit test, right? So build successful, and you can see that it's going through. After that, it goes to the Docker building. So you use a Docker file and stuff like that and build the Docker. So you can see here in the so this is the stage which I was talking about, the build Docker. So and this is the one another key parameter which you can use, or key which you can use, which is called parallel. So it means that all of these steps inside this stage, the stage RBA config DB, RBA data access and stuff like that, all will be executed in parallel. So it doesn't wait for another stage or another step to conclude to start this one of the sub-stages here. So this parallel block will help you to do parallel things, which are basically you can run things in parallel, which are not interdependent. So after that stage, you are going to the deploy in Kubernetes, and again that also you can do it in parallel. And as you can see, so in this deployment, in the deployment step, what I'm trying to do is, so there are multiple steps to do in the deployment, right? So I am using a Kubernetes YAML file and using an Ansible playbook to call that Kubernetes. I'm using an Ansible playbook to call the Ansible playbook, and then that Ansible playbook internally will be calling a Kubernetes file to deploy. So all of these Ansible playbooks, and so what you can see here is Ansible playbooks RBA config DB. So like if I say here, so this is the deployment file. So this is basically a deployment file which is the playbook file, which I am actually trying to see different backing up different configuration to ensure that always I have a clean file and stuff like that. So this is the playbook information or playbook which you can use to do a lot of tasks to get something deployed, right? So that is where the Ansible playbooks come into picture. I think I don't have enough time to talk a lot about the playbook and the syntax of it. So it helps you do a lot of these small tasks and automate a lot of these tasks, which helps you to deploy the infrastructure activity. So even this Ansible playbooks is not only for DevOps. We are really using Ansible playbooks in our non-functional environment as well, where you have, say, 15 machines to set up and then run a non-functional test, right, like a reliability test or a performance test. So you can really use Ansible playbooks to really manage that environment, to download the build and deploy, and you can ensure that each machine has come to a expected state, and then you can start the test as well. So Ansible playbook has a lot of applications, and you can use it in various different use cases. So here I am using the Ansible playbook basically to call the set up the environment and making sure that all my files are intact, and then I am running a kubectl command at the end to call a Kubernetes YAML file and deploying that into the CI. So this is a very high-level view of like how I am using Ansible and Kubernetes here. So, and I can basically look for, I am waiting for the service to come up, but I think in this I don't have the service to come up. So in some other file, you can see that, say, RBA collector. So you can see that I am waiting for service to come up, and I'm looking at making a request to one of the Swagger UI, and then finding out that it's coming up, and then that's how I ensure that this step is succeeded. So all of this I can do with Ansible. So the Kubernetes file which actually is getting called here will be inside the Kubernetes stuff. So one of the files which I probably would have called is the Kubernetes file. So I will not be talking more about all these tests, but yeah, so depends upon what you want. So your service needs to be exposed. You might need a load balancer configured, or you can really run with a node port if you don't want expose. So in my config DB, it needs to be exposed only to the internal services. So I have used that node port here. And for my RBA collector, I need a load balancer, which basically the user is going to access this file. So I have created a use the load balancer and expose the port 8080 outside. So each of this topic needs basically one session by itself. So I'm just giving you a high-level view of where and all things can be utilized and how things can be integrated. Okay, so what you understood right now is, say I'm going back to the Jenkins file where I told you about the Ansible playbook, where I am calling the Ansible playbook, and Ansible playbook internally will call the Jenkins file to deploy it. Okay, and so the next step is, so this is another stage which I have created where I am running the configuration test and then running the integration test. So this itself, I have created a Jenkins, the Ansible playbook to call different tasks of Gradle tasks. So Gradle tasks are inside the playbook. So Ansible playbook for integration test, suppose. So I have configuration test and integration test. So I have created some of the steps and then copying all the information to some results folder. All of this I can do with Ansible playbook. And what I am really running is this, which is basically a Gradle task, which is a functional test as the task, which is gonna invoke all the tests inside the repository. Okay, and again coming back here. So what you can see here is, let me go back to, so this is the pull request, right? So I told you, sir, right? So the pull request, which I have made it that only these tasks of building, deployment, and some tests have to be executed before it is before it can be merged, right? So this build is succeeded here and it's completely green. And now if you go back to my pull request here, and this is basically the Bitbucket where I made the pull request and the merge was disabled that time. So now the merge is enabled and you can create the merge request to the developer. Basically the one build which was a prerequisite for success or prerequisite for merging is done, and now you can create a merge. So now this is the time when it is actually getting checked into the develop branch, which is going to be a stable branch, right? And you can have intermediate branches as well, but yeah, in our case we have used it in this way. So what happens is that once the develop branch is merged, it again creates another build which is going to be running with the entire develop branch. And in such cases, whatever I have done, like the conditions were when branch develop, all these stuff will get executed. So in the develop branch build. So you can see that in the current view, we have skipped all of these stuff, right? So all of these steps will get executed in the develop branch. So it will take some time, and so any questions till now? I'm just filling in for the waiting time. I'll take probably 5 to 10 minutes more to conclude. So any questions till now?
No. Looks good.
Okay, so maybe I'll continue the explanation of Jenkins file. So the next stage which I have configured is nothing but a tool test, where I am really running an SS scan. This is where the security is actually injected to my pipeline. where I have a Docker for Nessus, and then that Docker file will basically get executed. So you need to have a Docker setup integrated with your Jenkins environment or the build environment, where that is basically a prerequisite for this. So this Nessus server can be really used for your manual execution as well, but this is one way to integrate the Nessus execution part of the CI, so which really help you to ensure that all the Nessus scan is done for each of the build changes. So this is one very important aspect of the security addition to the DevOps. So there are multiple steps which we are doing along with the security. So another step is basically the dependency license. So dependency license is so you file this ITLS and stuff in your for your code, right? So this gives you a list of dependency libraries, as well as it will create you whether all the dependencies are using a proper license and valid license or not. So this is basically a Gradle plugin again. So you can download the Gradle plugin for that and then execute it. So you can see this. I can probably show that part. So let me pull up one of my stuff. So in the build.gradle, what you have done here is, so these are some 3 lines which you need to add, right? So the OWASP dependency check is another tool which you can use. So I was talking about the license, dependency license report. So this is 3 things which you have to add. You have to add this plugin, and you have to add the repository. So the repository which is where this plugin is available is this, and then another one is the dependency. So dependencies is basically this class part. So these 3 lines.
Look, this Gradle plugin that you're talking about, that's pretty interesting, because it actually puts in a lot of dependency checks that you could actually add as part of your CI pipeline before building.
Yes.
What other plugins are available? What else you could do with these plugins?
So this will go through the entire code and then it finds out all the dependencies and then do it. So you can add more and more plugins. So I have used 2 plugins for now, which is dependency check, which is a OWASP dependency check library, and that plugin is again a Gradle plugin which you can use. And another one which I have used is the license report.
So it ensures that, typically what happens is many of the builds that is consumed by QA for further testing might fail due to dependency issues, and it may be overseen. So this kind of helps in bridging those gaps, is it?
It doesn't bridge that gap. So this is basically to find the OWASP vulnerabilities in the dependencies. Say my code needs a lot of dependencies. Krishnan, can you mute? Yeah, so if my code actually is using a lot of libraries, third-party libraries like Spring Boot, and I have a number of libraries which are going to do my functionality, right? So, so while we write the code, you keep adding different libraries to ease out your coding, and so this OWASP dependency check Gradle plugin actually does the vulnerability check for all the dependencies which you have added into the code. So, so that is one thing which will help you to ensure that whatever we are using the third-party libraries are not having any vulnerabilities. So that will give the heads up on we are using the right libraries, or if we are finding a vulnerabilities there, we probably will have to update our library and then proceed. So that's what the use of this OWASP dependency check. And the license report is nothing but it helps you to give a list of third-party libraries which you are using in the code, and you can file your ITLS and stuff like that. It will ease out your work on that. So it will also tell you that the proper licenses are being used and what are the type of licenses used for in the third-party libraries. So the integration is so easy is what I'm basically trying to tell. So in each of your modules, you can add this plugin addition, and you can give the repository from where you can get this plugin and the dependency. So these 3 lines will really help you to get it. So you can get this executed. So there is a Gradle task which gets added. So if you add these 3 lines and build it, you can see that, yeah. So you can get generate license report is a Gradle task which automatically gets added. So I'm basically using that Gradle task. So you can run it in your IDE itself. If you run the generate license report, it basically creates the license report, and you can basically get it in your machine itself, this license report. Or if you are putting that into your CI pipeline, then basically you have to add enough code to copy that license report to the root of your build repository and stuff like that. So that's also, this can be done as part of the IDE or as part of the CI. Okay, so here you can see as I merged, so it has started the develop branch, and as I had mentioned, all of these are going to be executed. So none of these steps are going to be what you call skipped in the develop test, because I have put the condition of when developed in this, and others I don't have any condition. So all the steps in my CA pipeline is going to be executed in this develop branch build. So let me go back to the Jenkins file. So the dependency license, so what I told you, right? So the dependency license stage, what I'm trying to run is basically the Gradle license report. So Gradle license report, it looks for all the Gradle tasks in the in my project, and then it runs the license report. And you can see that as well here. So you can see that it ran the Gradle generate license report for all of my sub-projects. So you can see that all the sub-projects, the Gradle license report has been executed, and the reports will have got generated. So the next tool I wanted to bring into your notice is the Claire. So Claire is a Docker vulnerability or the container vulnerability test tool, so which basically gets into each layers of your container, and then finds out the vulnerabilities, what are the libraries used there, or what are the things open for that. Right? So all of these vulnerabilities can be checked and then found out using the Claire tool. So that is getting executed right now. So here in this pipeline, here you can see that the Margate with Claire. So I am basically using a Docker container again for running this Claire. So the Claire again is like Nessus. You need to have a Claire setup separately, which you can. So right now, what we are using here is a Claire itself is a Docker container. So you bring up one Claire container and then run against my particular service. So each of them I will bring up one Claire container and then run the Claire test against my services. So there were some problems with the scalability of my setup. So I had to basically divide this Claire test into 2 stages. So all of these can be done based on your stage. So you can see Claire test phase 1 here, Claire test phase 2. This is nothing but all of them are executing my 6 services. The Claire is getting executed, but all of them I couldn't execute them in parallel. So I have put it into 2 stages to ensure that it is working successfully. So at the end of it, you gather the results from multiple places, from the results from the Nessus scan, and then you report that. So I tried to implement the quality gate for my project, but I haven't been I have not completed that, and so that I would not be able to show it here in this session. But maybe in some, if someone wants some information, I'm working on it right now. So if someone wants any information post this session, I can show you. So that is the stuff which. So at the end of it, what I am trying to do in the Jenkins pipeline is that after all of this, I am doing the gathering results. I am doing from SSCAN, and so all other stuff I have put the placeholder for now. So I have not really put a daily task for all of this. And at the end of it, so this is the stage for reporting and tagging where I am publishing all the HTML reports for the dependency license vulnerability report, Claire vulnerability report. All of this I am trying to execute, and at the end of it, I clean up the environment using the post always using the again the Ansible playbook. So here you can see that an Ansible playbook I am using to clean up the environment to delete all the containers. And at the end of it, I notify the Bitbucket saying that the build is success or it's failure. So yeah, so I think I have overshot the time, so I had to run quickly towards the end. Any questions? Any questions, guys?
This Gurmi, thank you so much, man. This is quite a comprehensive detail of all the organization does in an hour and a half. So not hour and a half, maybe an hour or so. It'll take. I'm sure it'll take some time for us to internalize, and I will definitely go through this recording once more before I can even think about asking some questions.
Okay, so this is the Kubernetes environment which I had used. So you can see that all the services are up here, and after the pipeline is done, basically all of the services will be deleted. So that is the cleanup task I was talking about. So there are, as I was mentioning, like there are a number of tools which are being used, and yeah, like Kumi said, kind of putting everything in 1 hour is a little tedious stuff. So yeah. So Rancher is one utility, or Rancher is one another deployment infrastructure which we have used to create a Kubernetes environment. So that also, I have a video, the YouTube video available for how to set this up. If you are interested, I can share that as well. Okay, yeah, thanks. If no more questions, I can probably go back to the slides and tell you that I have listed down this. You can refer later. So these are some of the tools which we have used, and I have given the links as well, so which you can basically get there and read through it. Okay, thanks everyone. Any last questions?
Hey, do you guys use JFrog for storing the built binaries?
I don't.
You don't? Okay. So it's directly into the Jenkins build that comes out of it. Okay. So, okay. That's all. That's the only question I had. Yeah. Any other questions for Anup? The floor is open. Okay. I would say it's a pretty comprehensive session, Anup. I think it gives a clear view of the dependencies and the way individual things happen within the CI pipeline. I mean, it's a very comprehensive demo. I would it would be good if all of us can go through that once again, in our free time, because this is anyway recorded, right? So you took real pains in preparing each and every step. So that's pretty good, Anup. So thank you very much for preparing this and doing this as part of this webinar, Anup. It's a great thing.
So Krishnan, at this rate, he can be a consultant. He can be a private consultant to companies who are setting up this.
Hey, Anup, you have a second job, man.
Oh, yeah.
Yeah, sure. That's what typically all the experienced folks do, right? After gaining considerable experience, right?
Yeah.
Sure. Okay. So I think if you have no more questions, we are done with the webinar. Now, I would like the core team members to stay back, and others can leave. Thank you, and have a good day. Bye-bye. Yeah, see you in the next webinar or conference. I'll let you know. I'll keep you updated on what it's going to be.
So Krishnan, as I said, I will have to skip the core team meeting. So maybe I'll take the notes from you or someone. Okay.
We'll see, because looks like we don't have we have just few people. Let's see whether we'll be able to do it or we'll have to do sometime else. But yeah, good job, Anup. Take care and thank you very much once again.
Thank you. Yeah, I'll leave. Thanks.
Yeah. Okay. All right. So. Yeah, Shubha, you can also leave because this is going to be the core team meeting. So you can leave. Not a problem.
Oh, sure.
Thank you, Shubha, for participating. I hope it was very helpful to you.
Thanks, Krishna.
Yeah. Okay, guys. What do you think we should do? I mean, we don't have Tina because she couldn't participate. She sent me a message. I is not there. We don't have the other person. Also, Anup is not there. So we just want to discuss in the upcoming Saturday because we have a core team meeting on Saturday. Or you guys have any ideas? So basically, what I want to do is to discuss few things. One is on how to improve the participation levels within the community. What kind of activities we could take up to, recreate the interest or improve the interest, and what should be our roles and responsibilities? Maybe instead of only me doing it, maybe some of us can take up additional roles. What kind of roles we could take up, and also, what is the? I mean, should we do our conference in August? What should be the theme? Those kind of things I want to discuss, but predominantly want to discuss about we have been active for 8 months, and to continue to be successful and active, what else we could do? So otherwise people should not start feeling little monotonous and bored with our regular webinars. So is there anything more we could do? That's what I wanted to do.
So, Krishnan, my thought is, sorry, there's an echo.
Yeah, one sec. I'll please stop the recording. I don't think this needs to be recorded.
Yeah.